Hello everyone. Yeah, let me just check that we are live. Mm, okay, I see Twitch is live and restream. I guess it should be, yeah, YouTube is live as well. So, yeah, yesterday we read about the storing list of values with vectors, and afterwards we play with the Rustling. It was kind of simple, but I still like it, so I'm going to continue today. We will read the book first and then I will do Rustling exercise. So yeah, let's start. Let me check my layout is okay, the camera is fine. So let's, as usually, quickly take a look what we read yesterday, and this is like storing list of values in vectors. So we find out about the vector. We also find out there is many data types vector in documentation for different purposes, and we can create vector from the standard library. We can push data for mutable vectors. There is an unsafe way to access the index, and I think we still can use it in case of, for example, iteration over the all items in the array, sorry, vector. But yeah, otherwise, if we not totally sure, we probably prefer to use get method, which is return the option value, option type, and we have to make sure there is actually a value. Otherwise, in this case, if there is no value for the index, it will be panicked. We also find out why it can happen, like why it's panicked, because in the heap, when we push data, no, it's actually about another example. It's, I guess, yeah, it's about this example where we have reference to the first element, but then we push item to the vector and try access this first element, and this is not possible. It produces an error because when we push the last element, the vector can be reinitialized in case there is not enough space, because vector place their values in heap next to each other, and there may be something else already stored next to the last element, and you need to reallocate the memory in heap. So what else? The iteration with for loop, the reference operator we saw, to how we can add value to a reference. We should do the reference. Vec exclamation mark is the macro to create a vector. And actually, yeah, one cool thing is you need specify what the type of vector you're creating, but in case like here, if we remove this code, there will be error that we don't specify a vector type, but if we do push, the Rust have known this is a number, and default will be for the number is i32, and it automatically can determine that this vector of I32. And I think this is cool feature as well. Yeah, I think this is basically it. Let's jump onto the text or storing UTF-8 encoded text with strings. All right. We talked about string in chapter 4, but we'll look at them in more depth now. Neurasticians commonly get stuck on strings for a combination of 3 reasons. Rust's propensity for exposing possible errors, string being a more complicated data structure than many programmers give them credit for, and UTF-8. So this is 3 reasons here. So one is UTF-8 has some complexity. String being a more complicated data structure than many programmers give credit for, and Rust propensity for exposing possible errors. Alright. These factors combine in a way that can seem difficult when you are coming from other languages, from other programming languages. This is exactly my case, actually. And yeah, we discussed string in the context of collocation because strings are implemented as a collection of bytes plus some methods to provide useful functionality when those bytes are interpreted as text. Okay, it's collection of bytes. Got it. In this section we'll talk about the operation on string that every collection type has, such as creating, updating, and reading. Okay. Not crude, there is no delete. We'll also discuss the ways in which string is different from the other collections, namely how indexing into a string is complicated by the differences between how people and computers interpreted string data. So yeah, kind of each characters usually encoded somehow, and for the computer there's special code for each character. For the human it's just a special character, you see. So this is different, so we have different way to encode it, and etc, etc. So the strings have some complexity, of course. What is a string? Well, we'll first define what we mean by the term string. Yeah, good start, definitely. Rust has only one string type in the core language, which is the string slice str. Str that is usually seen in its borrowed form of reference str. So Rust has only one string type. Okay, one string type in the core language. Okay. In chapter 4 we talked about string slices, which are references to some UTF-8 encoded string data stored elsewhere. Strings literals, for example, are stored in the program's binary and are therefore string slices. So literals stored in the binary and therefore string slices. Okay. The string type, which is provided by Rust standard library rather than code into the core language. So string is something is a part of the standard library and not of the core of the Rust language itself. Okay. Is growable, mutable, owned. UTF-8 encoded string type. Okay, let's use UTF-8. When restrictions refer to strings in Rust, they might be referring to either the string or the string slice reference str types, not just one of those types. So yeah, it might be some confusion because of two types. And they're both basically strings, but I guess it's similar for different languages, but yeah, it's not so important as in the Rust case, I guess. So let's find out more. Also, this section is largely about string. Both types are used heavily in the Rust standard library, and both string and string slices are UTF-8 encoded. Okay, and creating new string. So yeah, let me just mute myself for a moment. I need to fix one thing. Okay, I'm back. Sorry. I need to fix my chair. Creating a new string. So yeah, many of the same operations available with vect are available with string as well, because string is actually implemented as wrapper around a vector of bytes with some extra guarantees, restrictions and capabilities. So extra guarantees, restriction and capabilities. This is interesting to know. This is string is basically vector, but vector of bytes. I didn't expect it, but yeah. An example of function that works the same way with vect and the string is the new function to create an instance shown in listing 811. So yeah, as usually, let's jump and create new project and start to play around with the code. So cargo new strings 8.2 run the env, remove hello world, and what we wanna. Okay, I think I need to fix my layout a bit for better view here. I think this is fine, and maybe I don't know, maybe I should increase the code view. So yeah, font size basically. So yeah, we have this let mutable as string new. So before we read, maybe we can try something. What the LSP suggests us. Can we append, for example? compile suggested, but I don't think it exists because LSP is no append. But can we push? We can push what we can push. Push char, and we can push str, and str can just be like this, and of course let's try to print it. So cargo run yeah, works as expected. Yeah, this is I think important part when you're reading the book or watching some tutorial, to be curious how things work and try to not just copy paste or recreate the what you see, but maybe have some curiosity and do, oh, what will happen if I do this, or what, yeah, something like this, to testing, to understand it better how it's work. Is it if you can do the thing you think it work, like whatever. But yeah, let's continue. This line creates a new empty string called s, which we can then load data into. Okay, often we will have some initial data that we want to start the string with. For that we use the toString method. So we can do it differently. Okay, I'm going to use toString method, which is available on any type that implements the display trait as string literal do. Listing yeah, so we can do data to string. So if you do something like something like this, hello to string, and then we'll just work, maybe replace with world, and let's see if I will see hello world. Cargo run, and s is hello world. Yeah, exactly. Cool. This is nice. So this is string slice, like something, yeah, hello is str, reference to str, so and it called string slice. And the s is string. Yeah, okay. So yeah, the method works on the literal directory. We already done it. Yeah, this is string slice and this is string from std. Okay. This code creates a string containing initial contents. We can also use the function string from to create a string from string literal. The code in the listing 8.13 is equivalent to the code from listing 8.12 that uses toString. Okay. Because strings are used for so many things, we can use many different generic APIs for strings, providing us with a lot of options. Some of them can seem redundant, but they all have their place. In this case, string from and toString do the same thing, so which you can choose is a matter of style and readability. Yeah, this is for sure. If there is no difference, we can do string from, or we can just do the literal and dot to string, whatever we prefer. I don't know, maybe when you use Rust for some time, you probably will like this format, because I think this is something you will see some not the class, I would like to say class. String is what is it? It might be struct or enum. I guess it's struct. Can we actually take a look? String. Go to definition. Yeah, pub struct. So string is a struct. We can see it from the source code. And we can see that string is a struct of which is vector of u8, so vector of bytes, exactly what we read from the book just a few minutes ago. So the struct, and you can access it by two semicolons, but for now I think this one to string is looks to me like I'm reading from left to right, and okay, I have hello string. We are fine here, but yeah, we will see. As this all question get answers when you do some practice, when you interact with other people code, etc. All of those are valid strings values. Okay, so updating string can grow in size and its content can change, just like the contents of the vectee. If you push more data into it. In addition, you can conveniently use the plus operator or the format macro to concatenate string values. Okay, I would like to see it. Appending to a string with a push str and push. This is, we actually tried push str, and push is just literal, I guess. But let's see, this one we've done already. After these two lines, S will contain foo bar, so foo and bar. The push str method takes a string slice because we don't necessarily want to take ownership of the parameter. For example, in the code in listing A16, we want to be able to use st after appending its content to s2. So we have s1 mutable string, then we have immutable variable s2 bar, then we push st, so to append it to s1, and then we still can print what we have in the s2 string. So yeah, since it's immutable reference, there is no problem with it. If the pushStr method took ownership of s2, we wouldn't be able to print its value on the last line, sorry. Yeah, exactly. However, this code works as we expect. The push method takes a single character as a parameter and adds it to the string. Okay. Yeah, I want quickly test. Can we do as push? Looks fine. And what if we do the double quotes? Is it the same? No, it's not the same. It becomes string slice instead of char. So single quote means it's a char, and if we do this, what error we will see? Character literal may only contain one code point. Okay, this is also fine. Just testing things how they works. So okay, yeah, this is an example. Okay, but this is one is clear, and we can continue. Concatenate with the plus operator or the format macro. Often you want to combine two existing strings. One way to do so is to use the plus operator as you shown in listing 818. Yeah, so far this is I think I don't like about Rust. There's because maybe of his complexity, we use a lot of macros to simplify the code, which is make us working not with directly with the code like with Rust language, but some template like format is doing something underneath, right? But it's not just a method, something else. Maybe it's fine, I don't know, but just because we don't know everything about Rust, it's like adding some complexity to understand what's going on. Yeah. Anyway, often you want to combine two existing strings. One way to do so is to use the plus operator as shown in listing 818. So we can do S1 and plus reference to S2. So S1 has been moved here and can no longer be used. But S2 is fine. And what actually happened? Yeah, let's first of all copy this example and play with it a bit. So S1 I want maybe something like this. Oh my gosh. And S2 is okay, S1, S2. And we have an error, it's borrow move the value. And what if we do it like this? Okay, we cannot do it like this. Cannot add string to string. Concatenation requires an owned string on the left. Okay, this is what is going on here. And okay. So let's run it. Vault and vault. We're good here. What then happened if we remove the reference here and expected references to found string, mismatch types, expected string slice, found struct string. All right. Can we do it like this? Yeah, just playing with simple stuff. What we already learned before, but to memorize it and yeah, better understand how it works. So the string s3 will contain hello world. The reason is 1 is no longer valid after the addition, and the reason we used a reference to s2 has to do with the signature of the method that called when we use the plus operator. The plus operator uses the add method whose signature looks something like this. So I'm not sure, but I guess when it Rust C plus operator, it looks for the add function of the type. So take self and take string slice, 2 params. Okay. In the standard library, you'll see add defined using generics and associated types. Here we've substituted in concrete types, which is what happened when we call this method with string values. We'll discuss generics in chapter 10. Not so far already. We are somewhere in the middle of chapter 8, and yeah. Next chapter, error handling, also sound very interesting because seems like error handlings mean a lot in Rust. Like you dealing with error, compiling throw errors into your face all the time. I saw it on the streams, people who already using Rust, so very important topic, chapter 9. This signature gives us the clues we need to understand the tricky bits of the plus operator. Okay. The first S2 has S2 has an ampersand, so it reference, meaning that we are adding a reference of the second string to the first string. This is because of the S parameter is the add function. We can only add a string slice to a string struct we can't add two string values together, but wait, the type of reference s2 is reference to string, not is a reference str, as specified in the second parameter to add. So why does listing 818 compile? Yeah, good question. Actually, there is some confusion. The reason we're able to use reference s2 in call to add is that the compiler can call else. Yeah, I need to translate this word. And coerce, yeah, I get it. I can coerce the reference string argument into a reference str string slice. When we call the add method, Rust uses a deref coercion. Okay, this sounds like another term. Okay, deref coercion, which here turns references to into, yeah, this is the range which is create slice. Okay, we'll discuss the ref coercion in more depth in chapter 15, because add does not take ownership of the s parameter. s2 will still be valid string after this operation. Yeah, we already tried what is possible to use, what is not. Play around with it. Second, we can see in this signature that add takes ownership of self because self does not have an reference. This means s1 in listing 818 will be moved into the add call and will no longer be valid after that. Okay. So also let s3 s1 plus yeah, sorry, get some notification which distract me a bit. So also let s3 equal s1 plus reference to s2. Looks like it will copy both string and create a new one. This statement actually takes ownership of s1, appends a copy of content of s2, and then return ownership of the result. Okay. In other words, it looks like it's making a lot of copies, but isn't. The implementation is more efficient than copying. It looks like it making a lot of copies, but isn't. Okay, the implementation is more efficient than okay. Yeah, I don't really care about this statement right now. I don't feel like there is a lot of copies and there is any problems. I'm fine with it. Someday I will need to dive into it, but definitely not now. If you need to concatenate multiple string, the behavior of plus operator gets, and yeah, I need to check this word, unwieldy. Okay. Is it unwieldy? It looks not too bad. As for me, at this point will be tic-tac-toe. Okay, so I guess it works from left to right. one by one. So we do concatenate, move ownership to new instance here, then sum of it concatenate, return ownership, same here and same here then. Okay, with all of the plus and double quote characters, it's difficult to see what's going on. For more complicated string combining, we can instead use the format macro. Yeah, this one is much easier, but is it do the same? Is it takes ownership of S1? Let's find out. Maybe just and cargo run. Tick tack toe. So S1 ownership still there. So I guess it even more preferable. So format exclaim mark. This is actually what we maybe want when we concatenate the strings. But yeah, for actually for learning purpose, I like this one more because yeah, when like training ourselves to use reference, moving ownership, understanding how it's concatenated, etc. And the format is just a magic macro, which we don't know really what to do, but I guess it happened a lot, like we can make a lot of format macro in the Rust code. So this is preferable way. This code also set S to tic-tac-toe, and the format macro works will like println, but instead of the printing the output to the screen, it returns a string with the contents. The version of the code using format is much easier to read. It's true. And the code generated by the format macro uses references so that this call doesn't take ownership of any of its parameter. Yeah, this is what we find out ourselves. And actually, can we quickly look log macro? Yeah, we can see the documentation here. Create a string using interpolation or runtime expression. The first argument format received is a format string. This must be a string literal. The power of the formatting string is in the curly brackets contained. Additional parameters passed to. Yeah, basically we can see information here, and if we go to definition, there is macro rule, and this is something like black magic here. I will just close it quickly to not confuse myself. So yeah, let's continue with indexing into strings. In many other programming languages, accessing individual characters in a string by referencing them by index is a valid and common operation. Okay, however, if you try to access part of a string using index syntax in Rust, you'll get an error. Consider the invalid code in listing 819. Should we use some reference here? I'm curious how it works. I will try it myself. So I have the error, and yeah, and can we do it like this? No. Um, can we quickly, is it like this for the vector? Let vector, and can we have v1 as vec, oh, what's going on? Let's do it like this. Okay, yeah, I think we are good here. So this is what I was like to try with string, but it's not working. Okay. Cannot be indexed by integer. Interesting. Maybe trait index integer is not implemented for string. For following other types, implement trait range from. Oh, so we can do something like no. Cannot be known compilation time. Range from use size indexing. Okay, let's read about it more. There, and the note tells the story. Rust string does not support indexing. Strings that don't support indexing, but why not? To answer the question, we need to discuss the Rust store string in memory. So a string is a wrapper over a vector U8. Let's look at the sum of our properly encoded UTF-8 examples. Strings from listing 814. First, this one. So, yeah. Let me quickly check one thing. Okay. In this case, len will be 4. Yeah, which means the vector stored the string whole is 4 bytes long. Each of these letters take 1 byte when encoded in UTF-8. Alright. The following line, however, may surprise you. Note that this string begins with the capital Cyrillic letter D. Okay. Unfortunately, I know Здравствуйте. Z. Not the Arabic number 3. So this string is acrylic and it might be stored differently. Ask how long the string is. You might say Well, but in fact Rust answer is 24. That's the number of bytes it takes to encode Rust in UTF-8. Because each encodes scalar value in the string takes 2 bytes of storage. So yeah, acrylic take 2 bytes and English 1 byte. Alright. Therefore, an index into the string's bytes will not always correlate to a valid Unicode scalar value. To demonstrate, they consider this invalid Rust code. You already know that answer will not be the first letter. When encoded in UTF-8, the first byte of the is 208 and the second is 151. So it would seem the answer should in fact be 208, but 208 is not a valid character on its own. Returning 208 is likely not what a user would want if they asked for the first letter or the string. However, that's the only data that Rust has at byte index 0. Okay. Users generally don't want the byte value returned, even if the string contains only Latin letters. If okay, the valid code that return the byte value, it would return 104, not H. The answer then is that to avoid returning an unexpected value and causing bugs that might not be discovered immediately, Rust doesn't compile this code at all and prevents misunderstanding early in the development process. Yeah, I think it might be possible to implement this indexing, but it was the decision to don't do it because it leads to some confusion. Okay. Bytes and scalar values and graph clusters. Oh my. Yeah, this definitely sound like oh my. Another point about UTF-8 is that there are actually 3 relevant ways to look at string from Rust's perspective. As bytes, scalar value, and grapheme clusters, the closest thing to what we would call letters. Okay, as bytes, as scalar values, and grapheme clusters. Okay, if we look at the Hindi word, I actually learned the Sanskrit alphabet, so I was able to read it, but it's like oh, it's namaste, written in Devanagari script. Cool. It is stored as vector of U8 values that look like this. Okay. Yeah, Devanagari script isn't easy one. Yeah, it's like if you put 2 letters together, like vowels and consonants, it makes some union which look differently, and I guess you should encode it differently, so it's more complicated than Cyrillic. encoding. So that's 18 bytes and is how computers ultimately store this data. If we look at them as Unicode scalar values, which are what Rust char type is, those bytes look like this. Yeah, this is, you see this dashed circle, it's mean this symbol comes under this one, and this one goes upper above this one. There are 6 char values here, but the 4s and 6 are not letters, they're diacritics that don't make sense on their own. Finally, if we look at them as grapheme clusters, we'd get what a person would call the 4 letters that make up the Hindi word. Namaste. Okay. Rust provides different way of interpreting the raw string data that computers store so that each program can choose the interpretation it needs, no matter what human language the data is in. Okay. Final reason Rust doesn't allow us to index into a string to get a character is that indexing operation is expected to always take constant time. But it isn't possible to guarantee that performance with the string because Rust would have to walk through the contents from the beginning to the index to determine how many valid characters there were. So basically another reason is complexity that will be higher than expected. Yeah, this is example just to show us how complicated the strings are and all confusion that comes with indexing implementation. So we just don't have it in Rust. So slicing strings. Indexing into a string is often a bad idea because it's not clear what the return type of the string indexing operation should be. A byte value, a character, a grapheme cluster, or a string slice. If you really need to use indices to create string slice, therefore Rust asks you to be more specific. Rather than indexing using the square brackets with a single number, you can use square bracket with a range to create a string slice containing particular bytes. This is actually what I tried, isn't it? But I haven't done it like this, and in this case it works more or less expected. So v1 will be and h will be and clear cargo run. So yeah, first and the first exactly what we expected. All right. Let's do differently. Let's replace the Russian word with Ukrainian one. Вітаю. And let's see what output will be here. So we have S in this case. And run. And you see it's just 2 letters as expected. For Cyrillic it's 2 bytes per character. And it's exactly what we see. Here's S will be an str that contains the first 4 bytes of the string. Earlier we mentioned that each of these characters was 2 bytes, which means S will be, first 2 letters, the D. If we were to try to slice only part of the character byte with something like this, Rust would panic at runtime in the same way as if an invalid index were accessing in a vector. Oh, interesting. Let's try. So clear, can go run. The thread main panicked at byte index 1 is not a sharp boundary. It's inside V of Vitae word. Okay, yeah, it's something not safe. We don't like it. You should use ranges to create string slices with caution, because doing so can crash your program. Yeah, I already don't want to try do this in my app because it feels super dangerous. So methods for iterating over strings. We still can iterate over strings. As we see in the first error, there is some iterators. The best way to operate on pieces of string is to be explicit about whether you want characters or the bytes. For individual Unicode scalar values, use the chars method. Calling chars on the separates out and return 2 values of type char, and you can iterate over the result to access each element. Let's use our hello variable. Now it will be panicked because of this. So let's fix it. Yeah, see, it works. Alternatively, the bytes method return each row byte which might be appropriate for your domain. So use our hello again and do cargo run, and each byte is printed without any problem. And this is fine. This code will print the 4 bytes that makes up this string. Yeah, in our case it's like 5 characters, so it should be 10 UFC 1 to 10. Yeah, 10 bytes printed out here. Okay, but be sure to remember that valid Unicode scalar values may be made up of more than 1 byte. Getting grapheme clusters from string as with the Devanagari script is complex, so this functionality is not provided by the standard library. Crates are available on crates.io if this is the functionality you need. Yeah, I don't think we need it for now, but maybe someday. Maybe we'll do something with Hindi or Sanskrit. This is potentially interesting. So strings are not so simple. Yeah, definitely we feel this after the reading this section. So to summarize, the strings are complicated. Different programming languages make different choices about how to present this complexity to the programming. Rust has chosen to make the correct handling of strings data the default behavior for all Rust programs, which means programmers have to put more thoughts into handling UTF-8 data up front. This trade-off exposes more of the complexity of string than is apparent in other programming languages, but it prevents you from having to handle errors involving not ASCII characters later in your development life cycle. Yeah, it feels like a lot of pain to work with strings in the Rust. It feels, look, I don't know. Really, I didn't do it yet, but yeah, it's really handy when you like being in this hard situation. Before, like if you do something simple, it like feels like unnecessary complexity, but the day and there is some different scripts, language scripts, and you need to deal differently with each one. This is will benefit, I guess. The good news is that the standard library offers a lot of functionality built off the string and str types to help handle those complex situations correctly. Be sure to check out the documentation for the useful methods like contains for searching in a string and replace for substituting part of string with another string. So yeah, I imagine all this complexity, but definitely there is already built-in solution, and probably if there is required more solution, they also people created already for it. So Rust is more and more popular each day nowadays, so I guess it shouldn't be a problem. Let's switch to something a bit less complex, hash maps. So I think hash maps we will or finish it today. And no, doesn't look super big. Maybe we can do it and finish this chapter today. Let's try. Storing keys with associated values in hash maps. The last of our common collection is the hash map. The type hash map KV stores a mapping of the keys of type K to values of type V using a hashing function which determines how it places these keys and values into memory. Okay. Many programming languages support this kind of data structure, but they often use different names such as hash, map, object, hash table, dictionary, or associative array, just to name a few. So yeah, it's something similar, like familiar for us. So let's continue. Hash maps are useful when you want to look up data not by using an index, as you can with vectors, but by using a key that can be of any type. For example, in a game you could keep track of each team's score in hash map in which each key is team's name and the values are each team's score. Given a team name, you can retrieve its score. Yeah, I think there is no need comments. It's key value. We will quickly understand it on the example. We'll go over the basic API of hash maps in this section, but many more goodies are hiding in the functions defined in the hash map key value by the standard library. Okay, as always, check the standard library documentation for more information. Yeah, this for sure will be handy when we start using it. So create a new hash map. Yeah, let's quickly create new project, cargo, new hash maps A3. Run nvim and go to main src, remove hello world. So one way to create an empty hash map is using new and adding elements with insert. Okay, in listing 820 we're keeping track of the scores of two teams whose names are blue and yellow. The blue team starts with 10 points and the yellow team starts with 50. Okay. So we need create an alias, use std connection hash map. So use std collections hash map. Then let mat course hash map new. Yeah, I can guess what the error it is. It complains because we haven't explicitly provide the type of the scores. Type annotation is needed, yeah, as I said. But since we will have the type from the insert, we will not need it, same as we have with vectors. So just scores insert, let's do blue to string, then just try different types. Scores insert string from yellow 50. Oh, sorry, to string, and I guess we can print it. So scores cargo run, and you see we have k blue value 10 and k yellow value 50. All right, now that we need to first use keyword and add hash map from the collection portion of the standard library of our three common collections. This one is the least often used, so it's not included in the features brought into scope automatically in the prelude. Hash maps also have less support from the standard library. There is no built-in macro to construct them, for example. This is fine, I guess. Just like vectors, hash map stores their data on the heap. This hash map has keys of type string and values of I32. Yeah, we can ask the LSP what it is, and it shows hash map key string value I32. Like vectors, hash maps are homogeneous. Let me remind what it is. All of the keys must have the same type as each other, and all of the values must have the same type. So basically we will need to use enums to have different types as with vectors. We can get a value out of the hash map by providing its key to the get method as shown in listing 821. So to get I actually like to type it myself. Let team name blue, let core get team name suggested by the copilot, and there is no error, and let's try to print what we get. Score cargo run sum 10. Okay, we get sum 10 and unwrap or 0. So we do after get copy it, which is so we have the option reference, and copy it, do copy and convert it not to reference but for the value, and then we need to unwrap it, which is return the contained value consuming the self value. Because this function may panic, its use is generally discouraged. Instead, prefer to use pattern matching and handling the none case explicitly, or call unwrap or else, or unwrap or default. So I guess there is or, and we can, I will do -1. Go 1. Yeah, it was unwrapped just fine. We are good. And here score will have the value that's associated with the blue team, and the result will be 10. The get method returns an option reference to value, and we actually can try to see what happened if we have non-value. So cargo run, and we get -1 since we don't have such k as blue dash. If there is no value, that key in the hash map get will return none. This program handled the option by calling copy it to get an option I32 rather than an option reference I32. Then unwrap or to set score to 0 if scores doesn't have an entry for the key. We can iterate over each key value pair in the hash map in similar manner as we do with vectors, using a for loop. And of course, let's try it. So for k value in reference scores, and what we can do, we can of course print each k value and quickly run to see the result. So blue 10, yellow 10. It's exactly what we expected to see. This code will print each pair in an arbitrary order. Okay. Hash maps and ownership. For types that implement the copy trait like I32, the values are copied into the hash map. For owned values like string, the value will be moved and the hash map will be the owner of those values as demonstrated in the listing A22. Use, okay, so what we're doing here, okay, maybe simply create, sorry, not create. So let's And let's paste the code here. And what we want to try here, we can try to use field name and we shouldn't be able to do it because the ownership was moved, and you can see it. So borrow of moved value field name. Move occurs because field name has type string which does not implement the copy trait. Value moved here, so in insert we move the value and then we try to use moved value and it's not possible. So far so good, everything as expected. So let's print the map then, and map should work. Cargo run. Yeah. So we aren't able to use the variables field name and field value after they've been moved into the hash map with the call to insert. Yeah, exactly. We tried ourselves. We insert the reference to value into the hash map. The values won't be moved into the hash map. The values that the reference points to must be valid for at least as long as the hash map is valid. So yeah, the values have the reference point to the must be valid for at least the long as hash map. Okay. We'll talk more about these issues in the validator reference with lifetime section in chapter 10. Okay. Not far away. We are finishing chapter 8 and yeah. So updating a hash map. Also the number of key and values pairs is growable. Each unique key can only have one value associated with it at a time, but not vice versa. For example, both the blue team and the yellow team could have value 10 stored in the scores hash map. So key must be unique, right? So okay, yeah, it's clear. But value can be either any. So when you want to change the data in the hash map, you have to decide how to handle the case when a key already has a value assigned. You could replace the old value with the new value completely. Disregarding the old value, you could keep the old value and ignore the new value, only adding the new value if the key doesn't already have a value. Or you could combine the old value and the new value. Let's look at how do each of these. Yeah, let's jump onto it. Overwriting a value. If we insert a key and a value into a hash map and then insert the same key with a different value, the value associated with the key will be replaced. Even so, the code in listing 823 calls insert twice. The hash map will only contain the one key value pair because we are inserting the same value for the blue team key both times. And we can quickly test it. Okay, and yeah. Oh, we cannot do it. Yeah. So ownership was moved. So do it like this. Cargo run. Yeah, sorry. So you see we did 3 inserts, but 2 times we do insert for the favorite color, and second was test, so it replaced the blue value. This code will print blue 25, yeah, exactly. The original value of 10 has been overwritten. Add in a k and value only if k isn't present. Okay. It's common to check whether a particular key already exists in the hash map with a value, then take the following actions. If the key does exist in the hash map, the existing value should remain the way it is. If the key doesn't exist, insert it and a value, insert it and a value for it. Hash map have a special API for this called entry. That makes the key you want to check as a parameter. The return value of the entry method is an enum called entry. That represents a value that might or might not exist. Let's say we want to check whether the key for the yellow team has a value associated with it. If it doesn't, we want to insert the value 50 and the same for the blue team. Using the entry API code looks like A24. Listing A24. Okay. So let's start again with the code from the book. And what we see here, we have created hash map. We insert a value for blue, and with entry method, and we check if yellow yellow key exists, like have value in the hash map. If not, we insert 50 and same for blue. But for blue, we already have the value, so we should get yellow 50 and blue 10. Yellow 50, blue 10, exactly. The OR insert method on entry is defined to return a mutable reference to the value for the corresponding entry key if that key exists. Entry is defined to return a mutable reference, okay, to the value for the corresponding entry. But we are not doing anything with. Actually, what we're gonna do here, we want to try what it returns entry. And I guess this is something we do not know yet. Okay. But just quickly would like to test what the test will be. Entry of string i32. Interesting. And what this function do? Sure value is in the entry by inserting the default if empty and return immutable reference to the value in the entry. So value here value equal 32 is that value valid code mutable reference. So we should do the reference first. This is something I actually learned from the Rustlings, which we will do after we finish with the chapter. And let's try to run. So unused variable, but in the end of the day we modified the blue value is to 32. All right. I feel like I'm getting some knowledge into Rust, like I'm able successfully experiment with the code. So we don't write any minifier yet, but we are going forward. It's already 8 chapters behind us. So mutable reference to the valid corresponding entry k that k exists if that case exists, and if not, insert the parameter in the new value of the k, return the mutable reference to the new value. This technique is much cleaner than writing the logic ourselves, and in addition plays more nicely with borrow checker. Running the code in the list in 824 will print. Okay, this first call to entry will insert the k for the yellow team with the value 50 because the yellow team doesn't have a value already. The second call to entry will not change the hash map because the blue team already has value 10. Okay. Updating a value based on the old value. Another common use case for the hash map is to look up a k value and then update it based on the old value. For example, listing 820, I actually can do this. I updated the value based on the previous value, and you see it's now 32. Answer for the main question of the universe. So for the instant listing, 825 shows code that counts how many times each word appears in the sum text. We use a hash map with the words as k and increment the value to keep track of how many times we've seen that word. If it's the first time we've seen a word, we'll first insert the value. Yeah, this is a nice one called snippet. I would like to use it. And of course, I will comment out this one first. So we have string slice, right? Yes. Then we created hash map and we iterate the text with method split white spaces. Split white spaces takes the string slice and returns split white spaces. Interesting. The iterator will return string slices that are subslices of the original string slice, separated by any amount of white spaces. White space is defined according to the term of the Unicode derived core property white space. If you only want to split an ICII white space, instead use split ICII white space. Okay. So basically we check the entry of word. If it's not there, we set 0 and then increment it. So in case it's already set, we will get the value count for it and increment it. So I guess volt we see 2 times, so it should be have value 2 for it. You see hello 1, volt 2, and wonderful 1. Okay. So this code will print volt 2, hello 1, wonderful 1. You might see the same key value pair printed in the different order. Recall from the accessing values in the hash map section that iterating over hash map happens in arbitrary order. The split white space method returns an iterator over sub slices separated by white spaces of the value in the text. The or insert method return a mutable reference to a value for the specified key. We already research everything here. Here we store that mutable reference in the count variable, so in order to assign to that value, we must use the reference count using the asterisk. Okay, this is how it's called, asterisk. I need to remember this name. The mutable reference go out of scope at the end of the for loop. So all of these changes are safe and allowed by the borrowing rules. So hashing functions. By default, hash map uses a hashing function called zip-hash that can provide resistance to denial of service attack involving hash tables. Okay, there is some link here. Oh, it's just link to here. This is not fastest hashing algorithm available, but the trade-off for better security that comes with the drop in performance is worth it. If you profile your code and find that the default hash function is too slow for your purpose, you can switch to another function by specifying a different hasher. Hasher is a type that implements the build hasher trait. We'll talk about traits and how to implement them in chapter 10. Oh, finally, traits. I watching some videos about Rust recently, and yeah, the traits I see each time this word I face, but I'm not sure yet what it is, so waiting for chapter 10. You don't necessarily have to implement your own hasher from scratch. Crates.io has library shared by other Rust users that provides hasher implementing many common hashing algorithms. So, summary about the common collections. We saw vectors, text with strings, and the hash map. Vector strings and hash maps will provide a large amount of functionality necessary in programs when you need to store, access, and modify data. Here are some exercises you should now be equipped to solve. Given a list of integer, use a vector and return the median when sorted the value in the middle position. So there is several exercise. I'm not going to solve it today, but maybe next time we will do it. We'll see. I'll check them and then decide. The standard library API documentation describes methods that vector strings and hash maps have that will be helpful for these exercises. We're getting into more complex programs in which operation can fail, so it's perfect time to discuss error handling. We do the next. So yeah, I just stopped here, and before they finish the stream, as last time, I would like to play with the Rustlings. Maybe let's do a bit smaller. And what will be the good place to put the camera in this case? Let's try it like this and jump into the code. So primitive types. So we have an error, expected identifier found, keyword. So is evening. Yoo-hoo, we are done. Second task. Expected identifier is alphabetical. So again, we don't have a variable here. I guess your character. So we need char type here, I guess. Yeah, and this compiled. So something missed here, so len creates an array with at least 100 elements in it, where the how we can do this. I don't remember. Can we do it like this? Okay. Yeah, we can do it from 0 to 100, but if we do like this, it will fail. No, it still works. Okay, let's continue. Get a slice out of array where the question marks is so that the test passes. So we need to start from first to 4, I guess. So we take index 1, index 2, index 3, and the 4 is not included, but I'm not sure. Oh yeah, it's not included, so we need 5. Actually, no. Oh, we actually missed. Get the reference from 1 to 3. So it's resolve this assert. Okay. Destructure the cat tuple so that the println will work. Yeah, it's intuitively clear, but I actually already don't remember how to do it from the book, so it's nice to do these exercises. Use tuple index to access the second element of numbers. So numbers, yeah, exactly. So we're done with the primitive types, and I think that's it for today. I feel a bit tired of 2 hours of streaming. Thank you for watching. We'll see you in the next time.